We got two more problems to tackle. First one we're going to do is on the left. 3m squared plus 7 is equal to 2. And this one, just a reminder of where we are. We're dealing with the practice page of the notes. So let's go take a look. 3m squared plus 7 equals 2. Now, I didn't want you to start to get into some kind of habit of doing anything specific. So this practice page has examples of everything we've done, solving for the complex and use substitution. 3m squared plus 7 equals 2 feels super easy. Now, on this one, I don't have all three terms of a quadratic. I have the m squared term, and I have a constant term. I do not have the term with just m to the first power in it. So when I don't have all three, when I have the square term and some real number, I don't get everything on one side like I would if I had all three terms. Instead, everything with the m squared is going to one side, everything without is going to the other, because we're going to use the square root principle if we can, because it's super duper easy. 7 minus 7 is 0, 2 minus 7 is negative 5. M squared is not by itself because it needs to be divided by 3. I've got m squared is equal to negative 5/3. And we know what happens next. I need to get rid of that square because, again, the goal is to solve for m. Solve for m means get m by itself. Take the square root, but remember when you do that, you have taken, when you take that square root of a real number, it does require you to consider the positive and negative results. So this means m is equal to the positive and negative square root of negative 5/3. Now, there's a couple of things going on here. The first of which is this is complex. There's a negative under the root, so I can bring out the I, and that's going to leave me with root 5/3. Now, I have a radical in the denominator. That is not allowed, right? So I do need to rationalize the denominator. Rationalizing the denominator for us, for this problem, just means I'm going to rewrite the square root of a fraction is the same thing as a fraction of the square roots. And rationalize the denominator means make it so the denominator does not have a radical in it. So I'm going to multiply top and bottom by the square root of 3. Square root of 3 times square root of 3 is 3. And what do I have? I now find that m is the positive and negative I times square root of 5 times the square root of 3 is the square root of 15 over square root of 3 times square root of 3 is 3. This is the positive and negative. There's a lot going on in that answer. So what does my solution set look like? My solution set contains what? It contains root 15 over 3i negative root 15 over 3i. Okay. The I going at the end is just that traditional form for writing a complex number, so that you have that form a plus bi. In this case, our real portion is 0.